Okay, children, this video is about inverse and direct variation. Now this is a little review because we have done this before, but direct variation is when we have y equals and then a constant times x. And inverse variation is when we have y equals a constant divided by x. So as a quick example, tell whether x and y show direct or inverse variation or neither. If you're looking for it, you want to isolate y. So in this case, we'd have y equals, multiply both sides by 9, and that's a constant times x, so that would be direct. Okay, here if I got y by itself, I would be dividing both sides by x, and that becomes a constant divided by x, which is inverse. And over here, if I got y by itself, I would add 2. That's not a constant times x, and that's not a constant divided by x, so that is neither. Alright, so here's a numeric example. Y varies directly as x, and y equals 9 when x equals 3. Write and graph the function. So what we do is we read the first sentence, y varies directly as x. That's y equals a constant times x. And then it gives us values. So we're going to use those values, y equals 9 when x equals 3. So that means that our k, our constant, has to be 3. So if we're going to write the function, the actual function, it's going to be y equals 3x. And if we graph it, it will look like this. A line with a y-intercept at 0. Sorry, I didn't draw it very straight. This stylus is kind of hard to work with sometimes. And a slope of 3. In our next example, x and y vary inversely, and y equals 3 when x equals 6. Write and graph the function. Find y when x equals negative 9. Now it doesn't matter if I say x and y vary inversely or y and x vary inversely. It doesn't matter. Because if I said x equals k divided by y and I were to switch their places, I would have y equals k divided by x. It's still the same thing. Okay? And y equals 3. So I'm going to put a 3 in for y when x equals 6, which means that our constant k is 3 times 6, which is 18. So our equation, y equals 18 divided by x. All right, now we're going to graph this. This is what's called a rational function because it has x in the denominator. So this is going to look a little weird to you, but just go with it here. If I had x was 1, 18 divided by x, 18 divided by 1 would be 18. If x was 2, 18 divided by x is 9. If x was 3, 18 divided by 3 is 6, so it would be about right here, right? 4, 5. If x was 6, we'd get 3. So we have this curve. And it's going to approach 0, but it'll never actually touch it. Same thing here. It's going to approach 0 this way. If we went with negative 1, we would have negative 18. And negative 2, we'd have negative 9. And negative 3 would be negative 6. And negative 6 would be negative 3. It would look a lot like the other side. It would reflect around the origin here. So that's what our graph looks like. And then we were asked to find y when x is negative 9. So then we're just plugging stuff in. Y equals 18 divided by negative 9. Y equals negative 2. All right, so now we're going to talk about checking data for variation. If you're given a table or a list of values, if the y divided by the x is constant across that table, then that data has direct variation, and your constant will be y over x. If x times y instead is constant, then that shows inverse variation, and your constant k will be the x times y. So it looks a little opposite from what you're used to, right? Because y equals k times x here. This x would have to be times the k. or y equals k divided by x for inverse like that. All right, so here's an example. Let's determine the type of variation that this data shows, and then we'll find y when x equals 45. So I have x is 5, 10, 15, 20, y is 45, 22.5, 15, 11.25. So we need to check what is y divided by x? Well, 45 divided by 5 is 9. 22.5 divided by 10 is not 9, so y over x is not constant. Now let's try y times x. 5 times 45 gives us 225. 10 times 22.5 gives us 225. 15 times 15 is 225. 20 times 11.25 is 225. So our k is our x times y, which is 225. That tells me that we have inverse variation, because look, the x has to go under the k, right? Y equals k divided by x. And the equation then would be, let me use white, y equals 225 divided by x. So now if I wanted to know, well, what if x is 45? All I have to do is plug in a 45 for x. 225 divided by 45 is 5. And for good measure, here's another example of the same thing, determining the type of variation the data shows. This time, if I take y divided by x, I'm taking 6 divided by 1 is 6, 12 divided by 2 is 6, 18 divided by 3 is 6, 24 divided by 4 is 6, y divided by x is 6, which is our constant. So, if I'm going to write this as an equation, remember it has to be y equals 6x, y equals kx, y equals 6x. And so what happens, what is y when x is 7? Well, 6 times 7 is what? 42. All right, so in example 6, we want to write the general equation for each relationship. Specifically, ooh, I didn't even change the color, look at that. When I ask for the general equation, I just want k as a letter. If I want to figure out what k actually stands for, then I'm going to ask you for the specific equation. So I didn't give you any numbers here to solve for k, so when I say general, we're just leaving k as k. So if m varies directly with np and q, directly with all of them, m equals, directly is k times, and then np and q, we'll just say k, n, p, q, all multiplied together. Not added, just all multiplied. All right, r varies inversely with s and p. R varies, r equals, inversely is k divided by, and then s and p means they're both going to be in the denominator, k over sp. I could have written it like this, k over sp. S and p, so they're both being divided. All right, z varies directly with x and y and inversely with m. Z varies directly with x and y, so I want kxy. And inversely, we put it all over m. We don't do, some people want to look at this and they want to go kxy, k divided by m, and then think maybe there's two different k's. It's one k times x and y and divided by m, all in one thing. And then this last one, x varies inversely with the cube of y. I did that because I see this mixed up a lot. Cube of y, that's not cube root of y, that's cube of y. If I cube something, I raise it to the third power. So k divided by y cubed. All right, one more example, this time a word problem. Boyle's law states that for a constant temperature, the pressure P of a gas varies inversely with its volume V. A sample of oxygen gas has a volume of 50.25 cubic milliliters at a pressure of 20.6 atmospheres. Sorry for the typo. Find the constant of variation. All right, so it says the pressure varies inversely with its volume. So I'm going to write P equals, inversely would be K divided by the volume. And we need to know what is that constant. Well, I know that at a pressure of 20.6, I have a volume of 50.25. Make sure you put the numbers in the right place. Make sure you put the volume where the volume goes and the pressure where the pressure goes. So when I multiply, I get K equals 1035.15. So when it says write the specific equation, now we're going to, this was the general equation, we're going to write P equals 1035.15 divided by the volume. Okay? And then it says find the volume of the oxygen gas if the pressure changes to 15.2 atmospheres. So I'm going to put 15.2 in for the pressure. Remember, make sure you put it in for the right variable. Equals 1035.15 over V. If I'm solving for V, all I have to do is essentially switch these guys places. So take 1035.15, divide it by 15.2, and you get a volume of 68.102. And it's a volume, and our volume is in cubic milliliters. So I'm going to write milliliters cubed, or you can write the word cubic milliliters. And I'm done. And so you guys have a good rest of your evening, and I'll see you tomorrow.